The question now is that in electric circuits, we have electric potential difference and we have charges which are moving. So moving a charge inside electric potential means that we are doing or accepting power. So what is the power in the electric circuits? So the question is, what is the power in the electric circuit? If you remember, the work done to move a pointed charge or incremental charge with a potential difference V, the work is delta Q multiplied by the potential V. Actually, in electric circuits, the potential V is obtained from the battery. So the battery supports us with the potential, with the required potential difference, and according to this potential difference, the charges are moving inside the conducting circuit. So the value of the charge multiplied by the potential difference is the energy done or the energy accepted by the circuit. The value of the charge can be obtained in terms of the current as I delta T. So delta Q is actually I delta T because I was delta Q over delta T. So in this way, the incremental power or the incremental energy is I delta T multiplied by the potential difference V. Now, the power associated with the transfer rate is delta T, delta U over delta T. So the power V is the energy per time. So the definition of power is the rate of change of energy. So delta U over delta T is the power. So in this case, the power V would be the current I multiplied by the potential difference V. So the power associated with the transfer is the rate of electrical energy transfer, B equals I multiplied by V. Starting from this, we can say that this power is also the rate at which the energy is transferred from battery to the device. If the device is a motor, it will convert this electrical energy to mechanical energy. So if the device is a motor connected to mechanical load, this energy or the energy is transferred as a work done on this load. If the device is storage battery that's being charged, this energy is transferred to store the chemical energy in the storage battery. If the device is simple resistor, this energy is transferred as internal thermal energy, tending to increase the resistor's temperature. So if we are talking about very simple resistor connected to a battery, so the current through the resistor will increase the temperature of this resistor. The unit of the power to obtain it is the unit of volt multiplied by unit of ampere. The unit of the volt is joule per coulomb. If you remember this, joule per coulomb, energy per charge. And the unit of the current is coulomb per second. So effectively, volt ampere is joule per second, which actually the unit of watt, the unit of the power. So the unit of power, which is volt ampere, is actually the unit of watt of the unit of the power. Now, we said that the power in a circuit equal the current in this circuit multiplied by the potential difference in this circuit. So V equals I multiplied by V. But the relation between I and V is governed by Ohm's law through the resistance R equal V over I. So we can replace V by I multiplied by R. So in this case, it would be I multiplied by I multiplied by R. So the power in the resistance would be I squared R. Or we can say that I equal V over R. So the power would be V over R multiplied by V. So the power in the resistance would be V squared over R. But should it should be taken into consideration that this power is the power dissipated in the resistance. But I multiplied by V is the total power in the circuit. Even if the circuit was just composed by one resistance, so in this case the total power in the circuit is the power in the resistance, but effectively I squared R and V squared over R is the dissipated power in the resistance R. That's what we are saying here. We must be careful to distinguish between the two equations. B equals I multiplied by V applies the electrical energy transfer of all kinds. But B equals I squared R or V squared over R apply only for the transfer of electrical potential energy to thermal energy in device of the resistance. Alright? Even if the circuit is just one resistor, this value is the same as this value. As an example, you are given a length of uniform heating wire made of nickel chrome iron alloy called nichrome. It has a resistance R 72 ohms. At what rate is the energy dissipated in each of the following situations? One, if we have a potential difference 120 volts is applied across the full length of the wire. So the full length has a total resistance 72 ohms and we have applied potential 120 volts. So we can apply V equals V squared over R, and V here is 120 and R is 72 ohms. So it is 200 watts. The second situation, the wire is cut in half. What means cut in half? Cut in half, it means that its length has been reduced to the half, but the cross section is the same. So if it isn't cut in half, it means that the half of the wire has half of this resistance. Okay, so the half of the wire would be half of this resistance. It would be 36 ohms. Okay, now the potential difference is 120 volts applied across the length of each half. So we have the two halves and we apply this potential on each half. So each half will dissipate its own power and each half will have 36 ohm. So in this case, each half, the half power or the power on just one half wire would be the potential difference squared over the resistance of the half wire. It would be 400 watt. But this for one half, and it is required to find out or the voltage is applied at each half. So both of them are applied to voltage 120 volts. So the total dissipated power will be the dissipated power in the first half and the dissipated power in the second half. It will be twice this value. It will be 800 watts. Okay. All right. See you in the circuits.